Physics problems often look like a test of raw math. However, most NCERT numericals can be solved more efficiently by applying physical principles to bypass unnecessary calculations. Take question 2.4. We have a conducting sphere with a 12-centimeter radius and a charge of 1.6 times 10 to the negative 7 coulombs. Because it's perfectly symmetrical, surface charges create opposing electric field vectors. Inside, these equal but opposite vectors cancel completely. Recognizing this state of electrostatic equilibrium allows you to skip the math entirely. In any competitive exam, you can immediately identify that the field inside a conductor is zero and move directly to the next part of the problem. Outside, treat the sphere as a point charge. Substitute values, squaring the radius to 0.0144. This yields 10 to the 5th newtons per coulomb outside and 4.44 times 10 to the 4th at 18 centimeters. Success in these problems requires both conceptual accuracy and precision in scientific notation. Managing denominator expansion and decimal placement is what ensures your physics logic translates into a correct numerical result. Question 2.5 shifts our focus to capacitance. We start with a baseline parallel plate capacitor with an initial value of 8 picofarads. Capacitance is inversely proportional to the distance between the plates. When we slide the plates together to half their original distance, the capacitance of the system automatically doubles. We then introduce a dielectric material with a constant of 6. This material further multiplies the system's ability to store charge. You can calculate the new value quickly by multiplying the dielectric constant, the distance factor, and the original capacitance. Multiplying 6 by 2 by 8 gives us a final result of 96 picofarads. Understanding these proportionalities allows you to solve dynamic capacitor variations mentally. This approach saves time on objective tests where long-form algebraic steps are unnecessary. 3 identical 9 picofarad capacitors are in series across a 120-volt supply. Take 5 seconds. Use the shortcut on screen to determine equivalent capacitance. For identical capacitors in series, divide the individual value by the number of units. 9 divided by 3 gives 3 picofarads. Always perform a quick sanity check. In a series circuit, your final equivalent capacitance must be smaller than the smallest individual capacitor in the string. To find the potential difference across each unit, remember the fundamental rule. In a series circuit, the electrical charge remains constant as it flows through every component. Since the capacitors are identical and the charge is the same, the 120-volt total from the power supply must divide perfectly and evenly, resulting in 40 volts across each unit. We verify our work by adding those individual drops back together. 40 plus 40 plus 40 equals our original 120-volt supply, confirming our logic is sound. These 3 conceptual pillars, sphere symmetry, capacitance proportions, and series voltage division, transform complex numerical sets into manageable logic puzzles. Mastering these shortcuts is the key to both speed and accuracy.